Emerging technologies and how life would look like in the future. The areas of emerging technologies that we are tackling is about materials. Emerging materials is a multifaceted point managing the disclosure and planning of new materials. And emerging materials and nanotechnology is an interdisciplinary field of science and building, joining extensive variety of common and man-made materials that relates the structure, combination, properties, trial, execution, and material handling. And with nanotechnology, the most interesting about nanotechnology is that material have a property of changing size scale of their dimensions into nanometers. New techniques to create nanophase materials have arisen in the development of new class of materials. For instance, a nanomaterials with an average grain size of 5 nanometers has about 50% of atoms within the first two nearest neighbor planes of a grain boundary, in which significant displacement from normal lattice position are displaced. The basic idea being to produce in new disordered solid which contains a high density of defect cores whose 50% or more of the atoms reside in the core of the defects. An overview of current emerging advances containing the absolute most unique continuous improvements, advancements and innovation in material science with nanotechnology are: first, the graphene. Graphene is one atomic thick layer of carbon atoms arranged in hexagonal lattice. It is building block of graphite, which is used among other things in pencil tips. But graphene is a remarkable substance on its own, with a multitude of astonishing properties which repeatedly earn in the title a wonder material. Examples of graphenes are graphene in solar cells, graphene in batteries, graphene in nuclear power plants, and graphene in thermoelectric, and so on. Then, ano nga ba ang properties ng graphene at bakit ganito na lang karami yung gamit niya? Ang graphene ay ang pinakamanipis na material na kilala sa tao sa isang atom na makapal at kapaniwalang tibay, and approximately mga 200 times stronger than steel. Higit pa rito, ang graphene ay isang mahusay na conductor ng init at kuryente at may mga kagiligilo na kakayahan sa pagsipsip ng liwanag. Graphene is truly a material that could change the world, with unlimited potential for integration in almost any industry. And next, aerogel. This is a synthetic porous ultralight material, is 99.8% empty space, means dikit-dikit na sila, 99.8% na dikit-dikit sila. The end product of the supercritical drying of liquids gels such as alumina, chromia, tin oxide, or carbon, the material is strong enough to carry 20 times its own weight. Aerogels are open porous. The gas in the aerogel is not trapped inside solid pockets and have pores in the range of 1 to 100 nanometers in diameter. The extremely low thermal conductivity is also make it a highly effective insulation material. Then, The most common aerogels or the silica aerogel feels like styrofoam and it's transparent with a blue cast due to its thermal insulation qualities. Seen the picture, the crayons are protected for melting. Then the one question is, can aerogel stop a bullet? Yes, it is strong to stop a bullet in its track. To collect these delicate particles, each is smaller than a grain of sand, aerogel will gradually slow them to stop without damaging them or altering their shape and chemical composition. Then next, amorphous metal. It is also known as metallic glass. Is a solid metallic material with disordered atomic scale structure. The produce of amorphous metal must require an extremely fast cooling rate to prevent the nucleation of crystalline phases. Ano nga ba ang amorphous metals at bakit mas maganda ang amorphous metal kaysa sa ibang metal? Ito talakayin natin. Ang mga amorphous na metal ay mga haluang metal na may ibang kasangkapan kumpara sa karaniwang metal. Ang mga amorphous na metal ay may kakaibang struktura na nagbibigay sa kanila ng advantage. Hindi tulad ng karaniwang metal na may malakristal na struktura na kadalasan nililimitahan ang kanilang performance. At mas maganda ang amorphous metal dahil ito ay binubuo ng mga atom na may iba't ibang laki. Ang mga amorphous na metal ay may random na atomic microstructure. They do not face the boundaries or weaknesses that some more common metals with rigid or crystalline structures do. Sa makatuwid, ang mga amorphous na metal ay maaaring maging mas lumalaban sa pagsusuot at kaagnasan, mas matigas at hindi siya malutong. Although both crystalline and amorphous alloys are amorphous in the molten state, when they cool, amorphous alloys do not transform into crystalline structure. As a result, aspects which contribute to a metal's weaknesses such as crystals, columnar grains, and grain boundaries are not present, then presenting a metal that is unrevealed by the crystalline alloys. Next is the superalloys. Superalloys are heated resistance alloys of nickel, iron, nickel, and cobalt, which can be used at high temperature, often excess of 0.7 of the absolute melting temperature, frequently operate at temperature exceeds 1050 Celsius, which occasional work at temperature up to the value of 1200 Celsius. Dahil sa kakayahang sumagap ng matinding init, ito ay karaniwang ginagamit sa mga machines at engines ng mga public and private transportation tulad ng masasakyan. This example is yung engine ng aeroplano. And superalloys are highly strength, often complex alloys that are resistant to high temperature and severe mechanical stress and exhibit high surface stability. They are commonly classified in three major categories. This is in the first sentence, that is nickel base, cobalt base, and the iron base. Next is the conductive polymers. Conductive polymers, or more precisely is intrinsically conductive polymers, are organic polymers that conduct electricity. So compounds may have metallic conductivity, can be semiconductors. The biggest advantage of conductive polymers is their perishability, or mainly by dispersion, yung lawak nila. They are used in chemical sensors, electromagnetic shielding, anti-static coatings, corrosion inhibitors, etc. Then next is the metamaterials. Metamaterials compose materials typically composed of arrays of small metallic resonators structured on microscale or the nanoscale. Metamaterials are artificially engineered materials designed to induce customized properties in materials that originally does not exist. The metamaterials structure are obtained by making significant changes in internal material structure through different techniques. Then, saan nga ba nagagamit tong metamaterials na ito? Metamaterials are used for diverse and include optical filters, medical devices, remote aerospace applications, sensor detector and infrastructure monitor, smart solar power management, ground control, randoms, highly frequency battlefield communication, and lenses for high gain antennas. Then lastly is the materials for future is continuing develop. So scientists continue to make better materials that are stronger, lighter, and more functional than conventional materials. With advances in nanotechnology, new materials and material combinations seems endless. Materials for future is patuloy lang itong nag-evolve or nagde-develop. Yun na po.